Okay, now let's continue our discussion now. So
Yes.
from
Yes.
today, we are trying to focus on BGP attributes.
Actually.
BGP attributes. And in BGP attributes, let's go with the slide. Wait. So in BGP attributes, we complete our AS path discussion, right? AS path.
Yeah.
AS path.
Next up.
In BGP attributes, we complete our well-known attribute, not complete, okay? In well-known attributes, we complete our well-known mandatory attributes. AS path, next hope, self-command, and origin option. Remember, IEN question mark.
Yeah. Yes.
Okay. So today
Yes.
we'll focus on our next BGP attributes, local preference, local preferences, and we can discuss weight attributes. These are the topics for today. Weight attributes and local preferences. Local preferences. These two options we can discuss. Now,
Okay.
if you check here, this local preferences, it is a part of BGP discretionary attributes. So in well-known, we have two options. In well-known, we have two options. We have well-known mandatory and well-known discretionary. What is mandatory and what is discretionary? So in well-known attribute, in well-known mandatory must be recognized by all BGP routers, present in all BGP updates. Yes, these attributes must be present in BGP update. What? AS path, yes. Next hop information and origin information. So these information must be present in BGP update. It's required, it's must be. Now, if you talk about well-known discretionary, I'm talking about what? Well-known discretionary attribute. In discretionary attribute, we have local preferences and atomic aggregate. We are trying to focus on local preference and one Cisco attribute. Cisco attribute. Weight is a Cisco attribute for BGP. So what is well-known discretionary must be recognized. Yes, it is must be recognized by all BGP routers and passed on to other BGP router, but need not to be present in any update. It's not compulsory, GNC, okay? Clear my point? It
Yes.
present or not. It is not required, it not must be. But it must be recognized by all BGP routers and pass on to other BGP routers, but need not present in an update. And the example is what? Example is local preferences. So we can discuss BGP weight attributes and local preferences. What is BGP weight attributes? BGP weight attributes. Let's create a design first, GNC, okay? Let's
Yeah.
create a design. In design, we can discuss theoretical portion and practical implementation. So I have a simple design. This R1 is my branch router, GNC, okay?
Yeah.
This R1 is my branch router. And I have two ISP connection here. I have two ISP connection. This one is ISP1. This one is ISP2. So I have two ISP connection. Now, let's create a design. So these two routers I'm using in BGP. For example, these two routers, they are the part of AS number, for example, 200, AS 200, and my branch router, here I'm using BGP, and here I'm using BGP AS 100. So AS number I'm using AS 100. Now I'm creating some loopback here for routes. For example, 2.2.2. Here is a route 2.2.2.2 slash 32. And same 2.2.2, we R1 is receiving from R3. So 2.2.2, we have same route. Do you want to see clear my point? Same
Okay.
destination, same routes. For same routes, this branch office has two paths, ISP via ISP1 and via ISP2. Now, this one is what? For example, this one is ISP1, ISP1. This one I'm using as a ISP2. Let's try to prepare this design first. Wait.
But what about interfaces, interfaces, IP?
Interfaces, yes, I'm using 10.1.12.2/24, 10.1.13.0/24. Let's try to configure IP address R1, R1, R2. Now let's prepare this design first. Into this design, we are trying to focus on weight attribute in BGP. Interface fast Ethernet 0/0, 10.1.12.1. Mask, no shutdown, 0/1. 10.1.13. No shutdown. Show IP interface brief. Let's configure BGP also. Router BGP 100. I have two neighbor 10.1.12.2. Remote AS is 200. Neighbor 10.1.13.2. Remote AS. Remote AS is 200. Remote AS is what? 200. Oh, sorry, I'm using 13.2. Let me change IP address. Wait.
Yeah.
Let's go to BGP, and I'm trying to create this entry. Neighbor 10.1.13.2. Remote AS is for 200. Now let's go to R2. So fast Ethernet 0/0. 10.1.12. Mask. No shutdown. Interface loopback 0. 2.2. Mask. Okay, now let's try to configure BGP. So router BGP 200, neighbor 10.1.12.1. Before configure neighbor, let's configure router ID first because it's a BGP protocol. Router ID. So I'm trying to configure router ID manually, okay? Router ID manually. So BGP router ID. I'm using 22.22, not 22. Let's use any other. For example, 11.11.11.11. Now neighbor is what? 10.1.12.1. Remote ASS 100. Network I can advertise. Network I can advertise 2.2.2. Mask 255, 255, 255. Let's go to R3. Let's go to R3. Interface fast Ethernet 0/1. 10.1.13.2. 255, 255, 255.0. No shutdown. Interface loopback 0. And yes, same destination we have. Loopback 2.2. Now router BGP 200. BGP router ID. So I'm using router ID, for example, 44.44.44.44. Now neighbor is 10.1.13.1. Remote is 10.1.13.1. Remote is 100. And network I'm trying to advertise 2.2.2.2. Mask. Any problem into this configuration, UNC? Simple task. Let's start our verification. Let's start our verification. So on R1, I'm using show IP BGP summary command to verify neighbor information. Yes, I have two neighbor 10.1 dot. I have two neighbor here
12.
10.1.12.2 and 10.1.13.2, right? I have two neighbor. And if I'm trying to verify my BGP table information, show IP BGP table. So you can see now 2.2. For this destination 2.2.2, I have two route. This 2.2.2, I'm receiving via next hop is what? 10.1.13.2. I'm receiving via this side, right? I'm also receiving same route via next hop 10.1.12. BGP is not using load balancing technique. UNC, remember always, there is no
Okay.
load balancing concept in BGP protocol. No.
Mhm.
Load balancing we are using only in RIP, OSPF, and EIGRP protocol. BGP is not using load balancing technique. No. So my point is, you can see this 2.2.2. You are receiving this 2.2.2 via next hop 10.1.13.2 via 10.1.12. Yes, routes are coming from two sides. But in case this is BGP table, this is not a routing table. If I'm trying to verify routing table, then show IP route BGP. So you can see to reach this 2.2.2, I have a route via 10.1.12. This route is installed into the routing table. Clear my point? This route. This route is installed into the routing table. Why? Why this route is installed into the routing table? Why this route is because we have
Because
because we have two route, right? Here we have, my point is, here
this
we
one
have
is the best route.
this one is the best route. But why this one is the best route? Okay, I have for same destination 2.2.2 is coming via 10.1.13.2. It's also coming via 10.1.12.2. To reach this particular destination, I have two routes, but only this route is installed into the routing table. Why? So here our topic is what? Weight attributes. Our focus is what? Weight attributes. Our focus is what? Local preferences. We'll discuss this option. But before discuss this option, let's talk about why this route is installed into the routing table. You can check one more information. You see, wait. You can check it. Show IP BGP. You can see this information via this side. See, If route is coming via this side, AS is what? AS is only one AS. If route is coming via this side, coming from this side, then AS is one. So on both sides, you have same AS path, right? Same AS path, equal AS, one AS, one AS. Let's talk about, see, why this route is installed into the routing table. Let's go with the BGP slide. Let's talk about sequence. So this is the order of path selection in BGP. JUNC, can you hear me?
Yes.
This is the order of path selection in BGP protocol. Let's focus on this point. Let's focus on this point. The point is what? Router will first check high weight. The router will first check highest weight. So if I'm here on R1, if I am here on R1, if I'm trying to verify BGP table information, show IP BGP. So you can see via this side, via 10.1.13.2, via this side weight is what?
Zero.
0. And via this side, weight is also 0. So if routes are coming from different AS, the weight is 0 always. And here I'm talking about order of path selection in BGP. So the first option is what? Router will first check what? Highest weight. But here on both sides, we have same A. See, we have same weight, right? We are using what? Same weight. So there is a tie. If there is a tie, then tiebreaker is what? If there is a tie, then tiebreaker is highest local preferences. You can see right now there is no local preferences here, but the default
No
is
information.
100. But right now there is no local preferences. Default is 100. So here there is no local preferences right now. Prefer route or originated by local to the router. So these routes are not related with same router. These routes are coming from different AS. It is not generated by local to the router. No, local router, no. Prefer shortest AS path, but here via this side we have same AS, via this side we have same AS. So if there is a tie of AS path, there is a tie of weight, local preferences, and AS path. I'm not talking about MED right now. No, I'm not talking about MED. I'm not talking about this neighbor type eBGP, IGP metric. No, we are not using IGP protocol. We are not using old BGP here, old route. This is trying to prefer this one. Please read this information. You will see what? Prefer the path with
Lowest
lowest
neighbor
neighbor
BGP
BGP router ID.
ID.
Router ID. So if you go and check on
Oh,
design, if you go and check on design on R2 we have router ID what? 11.11.11. Right? We have router ID what? 11.11.11.11. Now, if you check on R3, router ID here,
four,
yes.
44. That's
Why
44. Okay.
why this route is installed into the routing table? Because via this side, what we have? Path, see, prefer the path with lowest neighbor ID. Lowest neighbor BGP router ID. So via this side, we are having lowest router ID, right? Do you see clear my point?
Yes, it's clear.
Via this side, we have lowest BGP router ID. That's why routes installed via this side. This is the reason. I hope it's clear for you. I hope.
Yeah, yeah, yeah. It's clear.
Now,
Very
now
clear.
let's go with the okay. Let's go to the R1 again. R1 again. So this route, my point is what this route install. You can see this symbol. You can verify this symbol. This greater than symbol. This star is what? Star is valid. So both the routes are valid, no problem. But this greater than symbol is only available via 10 dot for 10 dot, 1 dot, 12 dot. Greater than symbol means what? Best route.
Best, best route.
So roots are coming. My point is roots are coming via this side. Okay, this one is a best route. This one is a best route. Now in case, wait, show IP route BGP. So to reach 2.2.2, this one is the next route. Now in case, if I want to receive, my manager told me, please use this route to reach 2.2.2. My manager told me, no, please use this route to reach 2.2.2. So you cannot do anything. You cannot do anything in ISP router, right? We cannot go to ISP router and change router ID. It's not possible, right, UNC?
Yes, it's not possible.
Okay, I'm managing my branch office. I can only do any kind of configuration in my router. I don't know anything about ISP router.
Mm.
Okay, if I want my manager will be, please, I want to use this route to reach 2.2.2. I don't want to use this route to reach 2.2.2. I cannot go to this router ISP2. I cannot change router ID. I cannot change lower route. Not possible. I can only do the configuration in my router. So what I can do here? I can use wait attributes. I can use
Okay.
what? Wait attributes here. What is wait attributes? Wait
Mm.
is a Cisco attribute. What? It means this attribute we can use only on Cisco devices, UNC. Only
Okay.
Cisco devices. So wait is Cisco attribute. It tells how to exit the edge. And path with the highest
Okay.
weight. Path with the highest weight is more desirable. The point is what? The path with highest weight is more desirable. If you are receiving, if you are receiving routes, for example, locally injected routes, then the weight is 32768. My point is what? If you have R1 router, R2, R3, okay, they all are connected. They all are the part of AS number, for example, AS number 100. So if R1 is receiving some route information from different AS, for example, this is AS number 200. If R1 is receiving any route information, for example, 1.1.1.1. So in IBGP, it will send this update to this R2 and R3, and it will use wait. See, wait. Let me explain one more time. Wait. I choose a wrong example. Wait. Okay, so local injected route. Local injected route means what? If I have R1 router, for example, and if I'm receiving some route from R2, and they both are the part of AS number 100. So if R1 receiving route information 2.2.2.2, they will receive this route information with weight 32768. Clear my point?
Yes.
IBGP routes weight you can receive with 32768. But if R1 is connected with R3, R3, R3 is a part of AS number 200, for example. For example, R1 is receiving 3.3.3.3 information from AS number 200. So he will receive this 3.3.3 eBGP routes with weight 0. Clear my point?
Mm.
If routes are
Yeah.
coming from different AS, weight is 0.
Mm.
If route are
Mm.
coming from same AS, weight is what? 32768. That's why you can see here, if you check on R1, if you check on R1, if you check show IP BGP, you can see the weight, the default weight is what? 0.
Yeah.
Because routes are coming from different AS. If roots are coming from different areas, the weight is what? 0. If root is coming from same areas, weight is what? 32768.
Okay.
So my point is what? I want to receive this 2.2.2 via this side. What I can do? Via this side, weight is 0. Via this side, default weight is what? 0. So what I can do, here we have option highest, see, highest path with the highest weight is more desirable, right? So I can increase weight here. For example, I want to use weight 500. Here I want to use what? Weight 500. What I can do, I can go to R1 router. I'm here on branch router. I can go to BGP protocol, router, BGP 100. I can tell to my neighbor. My neighbor is what? 10.1.13. I'm telling to this neighbor 10.1.13.2. Command is what? Command, you can see here is a command wait. Here is a command what? Wait command. So neighbor 10.1.13.2 wait number you can select in between 0 to 55,500.
Oh,
Via this side, I'm trying to increase my weight 500, for example.
okay.
I can manage branch office. I'm trying to change weight via this side, via this ISP. Now I can refresh my routing table, clear IP BGP S3 command to refresh my routing table, to reset my routing table. Let's verify. Wait. After some time, we can verify.
That means the router will choose the way where the weight is high,
Yes,
right?
the higher weight is more desirable. Okay.
Oh, okay.
Now you can see show IP BGP summary. Yes, I have enabled. Now you can see show IP BGP. Now you can see to reach this 2.2.2. You can see to reach this 2.
Ah,
Now the best route is what?
the best route.
10.1.13.2. You can see now. Why? Because via this side, weight is what? 5.
Weight
Before this, if you check your routing table to reach
is
2.2.2,
0.
the best route is what? Via 10.1.12.2, right? Remember?
Yeah.
If you remember routing
Yes.
table, let me show you routing table. Before weight configuration to reach this 2.2.2, the best route is what? 10.1.12.2. But now to reach this 2.2.2, I have two routes, but via this side, via wait, via this side, we have highest weight. That's why this route is installed into the routing table. You can check now. You can check routing table here. Show IP route, BGP. Now you can see
Yeah.
clear now.
Okay.
But
Yes.
but he,
Yes.
but here we have a problem. Juancy. Okay, clear this
Yes.
command syntax.
Yes. This command sentence is okay.
Clear this output, Juancy.
Yeah.
But here is a problem. The problem is what? Problem is what? Let's go to R3. Let's go to R3. And I'm creating a new loopback. Let's create new loopback. For example, interface loopback 1. IP address is 22.22.22.22. Okay. And I'm trying to advertise this route in BGP. So network 22.22.22 mask. Let's go to R2 also. I have same destination. Network 22.22.22.22 mask. Let's create loopback interface loopback to 22.22.22 mask. Now let's verify route information. So my point is now I have one more destination 22.22.22.22. Here we have 22.22.22.22. So now if you check your BGP table again, show IP BGP. Now you can see. Now you can see.
Okay.
Now to reach any destination, the problem is what? To reach 2.2.2, to reach 22.22.22, the best route is what? The best route is via 10.1.13.2, via 10.1.13. The problem is what? I was looking for only 2.2.2, this particular destination. Now any destination, now any routes are coming via 10.1.13.2. All the routes are coming via 10.1.13.2. Why? Because via this side we have highest weight. Clear this point?
Yes.
Now I'm not utilizing this route. No, for anything. See, I have new destination 22.22.22. To reach this 22.22.22.22, I have two ISP connection. But routes coming via, all the routes are coming via this side only. Because via this side, we have highest weight. And when the route is coming via both sides, this router will decide via this side, I am receiving route with highest weight. So this is more desirable route. This is the problem. Clear my point? Do you see?
Yeah.
For
Yes.
everything, now for everything, 10.1 dot, 10.1 dot, 13.2 is an extra. So I don't want to do this. Okay, I want to, wait, my point is what? I want to receive this 22.22.22.22.2, this route, I want to receive via this side.
Okay.
I want to receive via this, but see, this particular destination, my point is, this particular destination, yes, I want to receive via this side, or you can say all the routes are coming. My point is, all the routes are coming from this side, no problem. All the routes are coming via this, no problem. But if you talk about this particular destination, 22.1, I want to receive via this side, and I cannot increase weight.
Okay.
You can see clear this point?
Yes.
So
Yeah.
what I can do, if you remember route map configuration, remember route map concept, route filtering topic, remember route map?
Yes. Yes. I remember.
Let me show you. No problem, no problem. If you remember route filtering concept. So we discussed our route map configuration. Route map we can use. Route map we can use in, I told you, route map we can use in redistributed route filtering. We can use in policy-based routing. Remember? Match,
Yes.
then set next hop. Remember match and
Yes.
set
Yeah.
command.
Yes.
So route map concept you can use in redistributed route filtering. Route map you can use in policy-based routing. And we complete our 4 lab on policy-based routing, source-based, destination-based, services-based, packet size, if you remember.
Yes. Yeah.
Now, again, I'm using route map. But in
PP
BGP policy
implementation.
implementation. So again, we are taking a help of route map. Let's go to R1. I can only manage branch office. Okay, I don't know anything about ISP. I can only manage branch office. So what I can do, I'm trying to create access list. Access list 10 format 22.22 wildcard marks. Now route map, remember route map command, route map name I'm using CCIE, CC, format, sequence number I'm using 10. Now match, please match IP address 10 and then set wait. Command is what? Set wait. So please match 10 and set wait via this side for this particular route. Please set wait 800. Exit. Now route map, CCIE, format 20. Now set wait this side 0. For this particular route, my point is what? Clear my point, Juvency?
Yes, yes. But
Yes, yes, yes.
I didn't understand why you, for the second route, CCA permit.
What I'm doing, let me do this. See what I'm doing. For this particular route,
Yeah.
I want to utilize this route for this 22.22, this route. I want to utilize this route for only this particular route. Remember this task weight attribute. The problem was if I'm using higher weight, this side. So for everything, my next hope is what? 10 dot, 1 dot, 13 dot. Is it correct?
This one
Juancy,
is correct. Clear. Yes, it's clear.
let me explain you one more time. My point is before weight configuration, the traffic was coming via this side, this 2.2.2, this destination. This route installed into the routing table, this one was the best route. Why? Because the lower BGP router ID, but I want to utilize this route. So the default weight is 0 this side, default weight is 0 this side. So I increase the weight via this side. When I increase the weight via this side, so for anything, for any destination, R1 will prefer this next home because via this side we have higher weight and the path with
Yeah,
the highest weight is more desirable. Clear this point?
this one is clear.
Now all the routes are coming via this side. The problem is what? All the routes are coming via this side. We are using BGP. In BGP, we can utilize path selection options. I want to see if I'm using weight attribute, all the routes are coming via 10 dot, 1 dot, 13 dot. I want to utilize this 10 dot, 1 dot, 12 dot. This route I want to utilize for this particular destination. For this particular destination. So what I'm using?
Yes, this
I'm
one.
using what? Route map. Route map. If you
Route
remember
map.
route map concept, in route map, we can use two command syntax, match, set. Match, set, right? So
Okay.
I'm trying to match 22.22.22. This particular route. I'm talking about this particular route. If this route match, set weight for 800.
Hmm.
Okay. And
Yes, this one is.
for rest traffic, weight is 0. For
Okay.
rest traffic,
Okay.
weight is 0. So now what I'm doing,
Okay.
once you configure route map, now you can go to BGP protocol and I'm trying to remove this command. Give me 2 minutes. Let's remove this command. And now neighbor 10 dot, 1 dot, 13 dot. Now I'm using what? Route map. Question mark. Route map is what? CCIE. and
Yes.
traffic is coming. Traffic is coming to the router. Traffic is coming to the router. So I'm using direction here. What? In direction. Traffic is coming to the router. Now, if you go and check clear IP BGP asterisk, let's reset our BGP connection. We can verify again. Taking time. Wait. Yes. Show IP BGP summary. Yes, I have two neighbors. Let's verify BGP table again. UNC, can you hear me, dear?
Yes.
So you can see now. You can see now. This 22.22.22.2 routes. This route, this particular route is coming via, wait. Now, this particular route is coming via 10.1.13.2 with weight what? 800.
800.
800. This particular route. And this same route is coming via 10.1.12.2 with weight 0. So this side we have higher route. So this route install. This one is what? Best route.
Best.
Clear my point?
Okay.
Now, if you talk about this 2.2.2 other routes, if you talk about other routes, this 2.2.2 rest traffic. So rest traffic is coming with this default behavior, right? Remember, if there is a tie, then tiebreaker is what? A route with the lowest BGP router ID, right? So via this side we have lowest BGP router ID 10.1.12.2 and here 10.1.13.2. Remember, if there is a tie of weight, tie of local preferences, tie of AS path, then tiebreaker is what? The route with the lowest BGP router ID will install into the routing table. Let me show you. Remember this line?
Yeah.
Remember this line? You can see.
Yes.
I hope this weight attribute is clear for you.
Yes, it's very clear.
BGP, I hope BGP is an interesting topic for you, I think.
Very interesting.
Yes. Let's continue our
I can.
discussion tomorrow, UNC. Tomorrow we
Yeah.
can discuss new design with new implementation. It's called local preferences. BGP local preferences. Okay.
Yes.
Bye,
It's
UNC.
okay.
Take care, dear.
Okay. Thank you. But I don't know if someone contact you about someone for
Yes,
course.
yes. I received a text message from one student. And thank you so much for your recommendation.
Yeah.
Really, I really thank you. Okay, so I discussed with student, okay. I discussed the timing and date. Okay. Actually, I am available after 23, 24. So I told him, and we are trying to set up the timing. You will see.
Mm, okay.
Okay.
Okay. It's
Let's
good
continue
for
our
me.
discussion tomorrow, Juvency. Okay, dear.
Thank you.
Bye. Take care, dear. Bye.